The time is Friday evening 6 p.m. Suddenly you get a new production issue. You are a Java developer. You look into the code and you see if else, if else, if else, around 300 lines of code. Not only you, there are many developers who do not have guts to modify this code because the impact is huge. How it all started? So whenever an order is placed, they want some kind of an order notification. So you started with sending an email first. If type equals email, send email of order. Within 3 days, you get another request. Can I get SMS also? After 2 weeks, the finance team called saying that if the order is beyond 500, can you send a Slack also? That's all started. And now 18 months over, and the same code become 500 lines of code. If else, if else, if else. This is not your situation only, it is many people's situation. Now this is the time where we need to refactor this code by applying design patterns. If at all you talk about this problem to any of the senior developers or the architects, they'll say, beta, learn design patterns first and then you can solve this problem. So no more production incidents on Friday. Hi there, my name is Achala Ramkrishna and I welcome to the playlist on design patterns in Java. There will be close to 25 videos as far as this place is concerned. I'm going to code in Java. Got it? And I just wanted to tell you that the concept and implementation both will be there. So I'm going to talk about the concept. I'm going to visually show using UML and code it in Java. Got it? Now, what exactly is a design pattern? Why do you need design pattern, right? This particular video is all about setting the rules straight. How many different types of design patterns are there? What are the categories, etc. Let's get started. What exactly is a design pattern? Now, I have found a new way to learn things. I'll just share it with you. I basically, you know, what is a design pattern? A design pattern is a proven way to structure classes and objects so they solve a recurring design problem. Hang on, do not run. Give yourself the time. So basically this is the definition of what exactly is a design pattern. Now I'll share you my approach. The first thing is what I do is I actually break that line into different parts. Now I I just put that in a bullet points and then I try to increase the font of it. See, I'm sharing you my secret way of learning things. I color the first one with red, the second one with green, the dark blue, and maybe with dark green. Okay. Now, basically, I try to understand. I don't care about that line which comes and goes by, rather than come over here, right? A design pattern is a proven way. That means other experienced developers have applied it and they have been successful. So it's not that something which is being invented today. To structure classes and objects, that means how you're going to organize classes and objects. The third point is to solve a recurring design problem. That means the repeating problem. If the problem is reoccurring, then only you apply that particular pattern. And the last thing is something which has worked for others. Okay. Now let us try to understand what exactly the design pattern is. A design pattern is a is something which has worked for someone else. A design pattern helps you in arranging the classes and objects in a given project. a, a design pattern, you know, is not a piece of code. So no, what exactly is not design pattern? That's a best way to do. It's not a stack, or it's not a queue, or it's not a linked list, or it's not a binary tree code. Okay, so rule this out. It is not data structures. What exactly is design pattern? Design pattern is not a piece of code you copy paste and you get it. It's not magic. Design pattern is neither a searching algorithm nor a sorting algorithm. Pattern is not a big architecture also. Design pattern fits into an architecture. Design pattern is needed to implement an architecture. Design pattern is not an architecture. You say, what is an architecture? A layered architecture, the pipe and filter, etc. A quick history of design patterns. I have read this particular book, Gang of Four, by four authors: Eric Gama, Richard Helm, Raf Johnson, and John Vlisidis. Just wanted to tell you is these guys didn't create design patterns. The book came in 1994. They worked with other experienced developers, architects, and engineers, and they have collected the good quality code, and then they derived these patterns. So design patterns is the hard work of you kind of people only. Okay, they have borrowed it. Got it? And they have borrowed this word pattern from the other from the other things, like constructions, architectures. Like if you want to, there are other architects who use the word pattern for the constructions, for other problems like towns and buildings, etc. So that's where they have actually borrowed it. I just wanted to tell you, for the next 30 years also, this particular topic, design patterns, will be relevant. And it's been 30 years why, where this is pretty much relevant too. How are you going to remember this design pattern? What's going to be our approach as far as this particular training is concerned? So what I'm going to do, I'm going to be very clear. I'm going to take each pattern and first tell you the intent of the pattern, why, the motivation, where it can be applicable, what is the structure. I'm going to draw a UML diagram to explain that. The participants, every class diagram will have the different classes, relationships, the participants, that I'm going to talk about. I'm going to I'm going to write a code also to explain this. Finally, once that particular design pattern is over, we're going to talk about consequences, when not to apply and not to apply. If you apply, if it is not needed, what kind of consequences you're going to face. So each video will take one design pattern and will actually move on. Now there are 23 design patterns. How are you going to remove it? Sorry, remember it. I'll tell you. It's a small and a sweet technique. I call that as a my technique. I don't get into each and every pattern. Rather than I try to see from a bird's eye view. How are these design patterns categorized? Correct. What is, how do I remember? So these 23 design patterns are categorized into three different ways: creational design pattern, structural design pattern, and behavioral patterns. Now what is a creational pattern? Creational pattern talks about how objects are created. Structural patterns talk about how classes and objects are organized or composed. Behavioral patterns solve different project situations. How objects interact is what behavioral patterns talk about. So there is a certain difference about it. So in a given situation, it's not true that you're going to apply a single design pattern. No, you're going to apply a mix of design patterns. Now some design patterns are classified based on scope too. Some design patterns are class level scope, and some design patterns are using object level scope. You need to understand that class level scope, that means it is fixed at compile time. Object level scope, that means it can be changeable at runtime. The one pattern uses inheritance, the other pattern uses composition. Now these are the 23 design patterns. So Singleton factory method, abstract factory, builder, prototype are creational patterns. Adapter, bridge, composite, decorator, facade, flyweight, proxy are structural patterns. Strategy, observer, command, template, state, chain of responsibility, iterator and mediator are behavioral patterns. You want to learn design patterns, you need a strong discipline. You need to spend at least an hour regularly and then you want to learn it. So do not uh, wait for design patterns to impress you. You become a student of it. You become a disciple of it, and then only design patterns will come to you. You're not interested to work hard design patterns. You just cannot learn. It will be an uncharted territory for your in you forever. And every time somebody asks about it, you won't have an answer. You'll feel the guilt actually. So, my dear audiences, my dear developers, please put aside some time in a day and start picking it up. Follow my videos, and I'm sure that you're going to do it. I'll try to bring it on, one design pattern on each day and finish this whole thing in a month's time. Promise. Let's do it. So, what exactly is a singleton design pattern? What exactly is a factory pattern? We'll get into it. Now, there are you need to have a strong foundation to understand design patterns. So, you need to be very good at object orientation. So, let's see whether we are good at or not. How patterns actually solve design problems? Let's get into it. Before that, we need to get our fundamentals straight. If you want to understand design patterns, then there are 6 prerequisites which you have to clear, or 6 steps. Now, the first thing you need to understand is how are classes identified in a given project, or how are objects identified in a given project. So, these are the 6 steps. If you understand, then things will be very clear. Okay. Now, what is the 6 steps? The first step is find right object, get objects at the right granularity, find interfaces, check for dynamic binding. You never code to a class, you code to an interface. You have to differentiate, you have to decide whether to go for inheritance or for composition. You need to apply delegates and apply generics as much as possible. So, these are all the things which are very important. Now, let's work hard. Let's not go hurry up. You need to know what is a class, you need to know what is an object. You need to know the objects at the granularity. What do you mean by object at a granularity? You need to understand what is an interface. What do you mean by dynamic binding? You have to understand what do you mean by programming to an interface and not to an implementation. You need to decide whether to create a inheritance structure or to go for object composition. You need to understand what do you mean by delegation. You need to understand what is generics. Now, these are all the things which you learn as part of Java is concerned. Now, let us start. Now, if you learn these 6 points, you can easily learn design pattern. But if you are not learning these 6 points, it will be tough for you because your foundation is not set. No? So, let's set the foundation first. Design pattern will learn automatically. So, what do you mean by the first step? Find the right object. So, whenever you are doing a project and let's say you have a use case of place and order. Now, most of the designers or developers, what they do to spot classes, they look for the tables. So, if imagine you have a database table like order, customer, address, item, blindly they design order class, customer class, address class, item class. 98 people out of 100 do that. Do you do? Then you are not doing a good job. You are not supposed to just replicate tables as classes and do object oriented projects. Why? I'll tell you what. Now, do not check for nouns only. Instead, check for responsibility. Who is responsible for this action? Who is responsible for this knowledge? That's how you decide on classes. Now, if you find that this entity should handle pricing policy, okay, this entity should calculate shipping. Now, it is not wise to put pricing policy and shipping calculator inside an order class. Instead, have two classes, like one is pricing policy, the second one is shipping calculator. What are we doing? We are designing classes, identifying classes based on responsibility. Who is the one who is going to have the knowledge of this? Who is responsible for this action? We are just not do not just spot nouns classes by just identifying on the number of tables. That's what it is. Did you learn it? This is a great thing. The second thing what it says is object granularity. Correct? Now I have seen something like a God object. You know what is meant by God object? A class which has got 1,000 lines of code or 2,000 lines of code. Nobody has got guts to break it. And here the second step of solving design problem, we are talking about getting the object at the right granularity. So do not create big classes, rather than decompose that at the right granularity. Try to decompose it. Now just wanted to tell you, in Spring, right, you have already lived this. You have something like at the rate service, the service class, and the it is just a facade, and there is a validator, there is a mapper, there is a repositor, etc., lying behind the service class doing the job extremely correct. Now if you are using the Spring framework for building a project, you see that the face of it is a service class, but behind it has been broken at the right granularity. So instead of one code handling service, validation, mapping, repository, proxy, etc., you have decomposed into several classes. So what this second point, object granularity, says that is, to solve design problems, get the right class. Do not overcomplicate it and make a big class and all. Yes. Now I want to tell you one thing which is very important. In today's interviews, there was, have you written any design patterns? My favorite answer to this particular question is, all the good work has been created by the people who have built or developed frameworks like Hibernate and Spring. By using Hibernate and Spring framework, without my knowledge, I am implementing most of the design patterns. So the younger generations may not exactly see design patterns at the code level, because if they are using Spring framework, that means without their knowledge they are automatically using the design pattern. Now let us get into the third point. Third point is, find interfaces and try to implement typing or runtime polymorphism. So it is very clear, in that same use case, see, do not code for a class. The problem is, let's say you are implementing a Zomato kind of an application, and then the customer wants to make a payment using HDFC payment gateway. Now do not write a code where you only use HDFC implementation. The problem is, the same customer will say that I have another SBI card to make payment, and his friend will say no, I have HSBC. Now if you write code for a class, the code will die eventually. If you write code for using an interface, at runtime you can start bringing in new implementation. That's what is polymorphism is all about, correct? So this is what it is: program to an interface, not to an implementation. If you want your code to outlive you, code for an interface, do not code for an implementation. The other thing which you need to know about design patterns is, when to go for, there is something like class inheritance, there is something like object composition. Class inheritance, that means using inheritance or composition. So if you are trying to come up with a new derived class to solve the problem, that is inheritance. If you are instead, if you are trying to use composition, that is one to many, one to fixed has a relationship. So you see, inheritance is in red color and composition is in green color. That means, um, what exactly here it means that is, if you go for class inheritance, every time you have to create new classes and you have to extend the functionality. Instead, if you go for composition, you can actually uh, at runtime, alter the implementation from one implementation to another implementation. So composition is favored anytime. There are other topics like delegation, generics also you should extensively use so that you can actually solve the design problems. Yeah. So, okay, what are the 8 habits that quietly force a redesign? Check this out. The first thing is hard coding a concrete class name everywhere instead of going through interfaces of factories. So, if you see that any of the code is directly creating a class, creating an instance and using a class straight away, and if it is a good project, there is a redesign situation. Okay. Now, if you happen to use Spring framework, then you hardly, so the step number 1 says that do not create an object using new operator for a class, rather use interfaces for its implementation factories. The second thing is code tied to one specific operation. A new variant brings, suppose you say process order. Okay. Now what happens is, if there is one function and then there is a small variations coming in, then what will happen? You're going to start getting into the world of if else, trying to, so do not write a big processing logic in big logic with different variations inside one function, correct? That's where you need to redesign your code. If your application is talking to one database, one operating system, one vendor API, you are bound to redesign, is because after 2 days you will come up with a different requirement, a different vendor API, then your code breaks down. So you have to you're forced to redesign actually. Fourth point, reaching into another object's internal fields instead of its public contract. So if you happen to start accessing the private data or protected data of other classes straight away, that means something is wrong in this area. You need to refactor and redesign. Again, the fifth point, as I was telling you, if the whole algorithm is inside one method, then you have to refactor. If class A and class B are so tightly coupled, then you need to break it. And if the only way you think that by extending the behavior is by subclassing, then you have to redesign the code. And if you are extensively using third-party libraries, right, or the generate code, which are not at all easy to modify. If you can't modify, you have to redesign. So in your projects, if I sum up, if you are directly using classes instead of interfaces and factories, you have to redesign. If you are only calling, if the code is tied to one particular method name only, then you have to redesign. If you are talking to a single vendor API, and tomorrow if you expect more different vendor APIs to be used, you have to redesign. If you are using other classes in private data or fields and not using the public methods, you have to redesign. If the whole algorithm is inside one function, you have to redesign. If the classes class A and class B are tightly coupled and you can't break it down, then you have to redesign. If you are only thinking about extending by subclasses only to solve it, you have to redesign. And if you think that I can't modify this code because it is from a different third party, but I have to change it, then you have to redesign. So there is a lot of place to redesign or refactor your code, and one of the best way to redesign is refactoring using design patterns. So we're going to discuss about how to select a design pattern, how actually we use the pattern we picked one, etc. Now one thing which I wanted to, I will get into this in details. Okay, These are the 2 points which I wanted to talk about. Before the patterns, things that only look like design is there is some big god object which we use. Imagine you are writing 3 lines of code and you got excited with design patterns. And for writing that 3 lines of code, if you are writing 6 classes so that you want to use an X design pattern, hold on. Do not use design patterns unnecessarily. Correct? Don't use it. Use design patterns when the key takeaways of introduction to design patterns. Number one, every pattern has a name, it solves a problem, it caters to us, it has a solution and it has got its own consequences. Do not judge design pattern as just a piece of code only. Never code to a class. Always program to an interface, not an implementation class directly. Favor composition over inheritance. And if there are 8 causes for redesign, if you find it, then definitely you'll find a placeholder for applying design patterns. And when you have few lines of code, like 3 lines of code, then do not create 6 classes just because your favorite design pattern you want to code. Please don't do that. I, Achala Ramakrishna, want to sincerely thank you for attending this particular video. I also conduct corporate training in Java full stack development. I conduct weekend courses on Java, Spring Boot, Spring Microservices, React, Kafka and all. Got it? Now please WhatsApp me if you are interested. Please subscribe to Robodynamics YouTube channel, like this video and share it with your friends. Wish you all the best. Bye bye. Thank you.